So, in the discussion of design thinking approach in vector calculus. So, you know, vector calculus is the area where we study about quantities that has magnitude and direction. It has a magnitude and it has a direction. So, we are going to calculate, we are trying to do some calculations using vectors. So, connected to engineering problems. Connected to engineering problems. So, because in engineering, we have lots of real-time scenarios where we are in need of vector calculus. Vector calculus. You know very well, velocity is different from speed. Even though in both forces involved, velocity is a vector quantity, scalar is a what? Speed. Scalar is connected with speed. So velocity is a vector quantity, speed is a scalar quantity. So likewise, vector quantities are of more importance when it comes to engineering. Okay. For instance, let us discuss about fluid mechanics. Okay, fluid mechanics. So when I am talking about fluid, I can talk about wave forms. Fluid move in a form of wave. Sound move in a form of wave. Heat move in a form of wave. Am I right? So heat transfer is a kind of wave motion. Fluid transfer is a kind of wave motion. Then what is next? Sound transfer is also in a kind of wave motion. So when it happens in a proper direction, they can be combined with vectors. So in fluid dynamics, what is the major role of vectors here? So we are talking about fluid. We are talking about fluid. Now, what is the connection between design thinking and fluid mechanics? Okay, that is our intention to discuss today. First of all, fluids. For example, let us consider. Let us, for instance, take crude oil. Some from the oil from a refinery, which is too far from our factory or from our place. So it has to be taken from a particular point to our place where we need to use. Alright. So we need to use it. Now, in the transfer of fluid, there can be various disturbances. For example, this fluid is oil. You are going to transfer this fluid from a place far away place to your place where you are going to use it. Okay, a commercial area where you are going to use it. Now, in the pathway, there can be a lot of hurdles. For example, temperature difference will be there, lot of heat may be involved, lot of pressure may be involved. These are some problems that you have to take care. Okay, that is the empathy. That is the pain point for an engineer, for a company to tackle it. Okay, so for that you may think about some solutions. So because different fluids. So now, so the first point, empathy. You have to understand the real-time problem. The real-time, because the density of the fluids are different. You know, petroleum. When the sunlight is more, when the heat is more, the density of the petrol varies. Have you ever heard of it, petroleum? The density will vary because when heat is more on the fluid, due to temperature difference, the density will vary. So accordingly, see 1 liter of petrol, when you get 1 liter of petrol in the mid sun, that is in the afternoon time, the hot sun, after getting it in the evening, if you see, it may not be the same 1 liter. It can be little lesser than that because the density goes so lighter when due to more sunlight. So likewise, there will be lot of issues, lot of problems, lot of hurdles. So in order to rectify why we need a proper idea. So that's why we come across define. So we have to define the problem. What is the real problem? We have to understand. So then we have to search for some methodology to understand to solve that scenario. Maybe accordingly the pipeline should be strengthened. Maybe a lot of innovations can be done in innovation. So we can go with some ideations, some methodologies, and we can find one proper idea. With that, we can work with. Similarly, we are talking about robotics also. So in robotics, maybe the robotics, the humanoids, to make the humanoid behave like a real human, according to adjust their speed levels, according to the body language, all those stuff. Even we can consider that as one of the problem, and we can ideate some methodologies and we can try to get some solution. So let us fix. Then we can fix some prototype for it. So after fixing a proper methodology, the right suited methodology for that scenario, we can validate it. We can validate and we can test it and we can understand whether that methodology is properly suited for that scenario. Okay, thank you.